Okay, good. Are you all able to see my screen now?
Yeah.
Oh, very good. All right, so this is a presentation on ham radio fox hunting. It's also known as amateur radio direction finding. And I was talking to Hoop about this. It's actually apropos because this weekend is the International Fox Hunting Weekend. Not only is it steeplechase, which was sort of a fox hunting thing anyway, but for ham radio, this is actually the weekend where they kick it off. The weekend before Dayton goes on. So there's a lot of amateur radio fox hunting contests going on today and tomorrow, as a matter of fact. And so the big question is, why do we want to do direction finding? This is something that we started in WCARES, Dave, what, maybe 10 or 12 years ago, and then
we were still at the Shoney's.
Yeah, a long time ago. Back when we were having the chew and chat, it was actually a chew and chat at the Shoney's. So why do we do direction finding? Well, you might want to use it to find a stuck transmitter. We did this when the EMA had a stuck transmitter on their Let's Talk statewide linked repeater system, and several of us helped track that down. Bill Jorgensen asked us if we could track it down and see if we could help. Otherwise, they were going to have to spend several $1,000s for a commercial radio direction finding team to come and track it down. And he used a bunch of us that were using these kind of antennas that I'm going to be talking about today, and our equipment that I'm going to be talking about today. And we tracked down their stuck transmitter. They were able to pull it off on the air, get it fixed, and things were doing better. We might use it to track down interference, either intentional or unintentional. So let's say we've got somebody that's a kerchunker that is trying to cause trouble and interfere. We've tracked several of these down. Also, you can have an unintentional. I remember one direction finding we did with the guys out of the Nashville group, where one of their, I think they had a stuck on the APRS frequency, and it was a fellow that had left a handy-talkie in his car, and it had slipped down between the seats, and the seat was pushing the transmit button, and it was completely blowing out everything. We might want to use it to locate noise sources. So you've got some really loud noise at your home QTH. You use it to track down where there's the broadband noise causing some of the issues. We can use it for search and rescue using downed aircraft. You know, all aircraft have ELTs, the emergency locator transmitter. In civilians, it's on 121.5 AM. And so if there's a sharp hit on the transmitter, it starts transmitting. And that's, they also have the EPIRBs now that goes on satellite, but for local tracking down, they all have ELTs. And then we can also use it to introduce non-hams to our hobby, because you don't have to transmit unless you're the fox. And the fox will be transmitting, but all the hunters don't have to use any transmitter. They just use receivers. And then it's also a lot of fun just to have fun in the outdoors. And we usually do this outdoors. Inside, it's a little bit difficult because you get multi-path reflections of the things. And in fact, when I turn on the transmitters today, I'll sort of give a demonstration, but inside this room, the demos are not going to be really good because we're getting the signal bouncing off all the metal in the room, and we get a lot of multi-path interference. So when I demonstrate it here in the room, don't take this as how it works, you know, in free space. It works differently in free space, but I know in the room it's going to be messed up. I've just done it before. So what type of equipment is needed to do a fox hunt? Well, you've got to have a transmitter that can be hidden, and I'll show you a couple of different varieties of the transmitter. You've got to have a receiver for the hunters to find the fox, and then you've got to have a means for determining the direction to the fox. Where is it, and in what direction is it? So how do we find the direction to the fox? Well, we could look for signal peaks. Also, we can look for signal nulls. And depending on what type of antenna we're going to use, we'll either use antennas that do peaking or nulling. And I'll point both of those out as we get to it. So let's get to it. What type of antennas do we use? Well, the rubber duck on your handy-talkie is not really a great direction finding. It's omnidirectional. It's all direction, so it really doesn't help. But there are some tricks that we can use down and dirty that can use this, that might help. We might want to use directional peaking antennas. That would be a YAGI antenna, and I'm going to give demonstrations of all of these. And then we can use directional nulling antennas, such as a loop antenna. This is going to cause a null, pretty sharp null. And then we can also use antenna arrays using so-called pseudo Doppler system. And I'm going to talk about all of these as we get into the lecture today. So how do we use the rubber duck on the handy-talkie? Well, you could use the handy-talkie with its rubber duck, and you could just use body blocking, where you put your body between the source and attenuate the signal a little bit. You could also consider using something like a Pringles can that's lined with foil and a slit cut out, or just what I did here, which is a paper towel roll, and I taped, and I'll show these to the Zoom people when I finish with the lecture. I'll bring everything up and go on video on the Zoom for the Zoom people. But this is a paper towel roll that I put aluminum foil probably around 3/4 of its length and left a vertical slit. And you could drop this over the handy-talkie rubber ducky and use the opening, but block the opening with the aluminum foil, and then have the opening to point towards the antenna. So you sort of attenuate the signal that way. There you are, a Pringles can, a paper towel roll with foil over the antenna. And then the other thing you can do is try tuning off of the frequency just a little bit, where you're sort of in the pass band of the frequency. So if we're using a frequency, a Fox hunting frequency of 146.565, which is what is sort of the accepted frequency here in the United States, try tuning to 146.57 or 146.560. The other thing you could do is, if you've got a dual band handy-talkie, is go to the third harmonic. So if we're on 146.565, multiply that times 3, and you could listen on 439.695. So the third harmonic is going to be significantly less. You'll have some attenuation. The other thing, if you take a look, it's better to have a receiver with a good signal strength meter, because we're going to use the signal strength meter rather than our ear to find where the Fox is. And I'm going to show both of those again after the slides are finished. I'm going to go over to the camera for the people on Zoom and zoom up on there so they can see what I'm talking about. So let's talk about antennas for peaking, for peak searching. This is a tape measure YAGI by W2HOL. And at the end of the lecture, I've got all of the links to pick up this information and get the information. These are pretty easy to make. I see several of our members have brought them in today. These are great fox hunting antennas. They cost maybe 10 or 12 bucks worth of material, just some PVC pipes, some hose clamps, and tape measure that you've cut to length. Now, this is the performance data from WB2HOL's article about this antenna. And this antenna is a YAGI antenna, which has some gain, but the important thing that I'd like you to pay attention to is this front to back ratio, greater than 50 decibels. Now, what does that mean? What does a front to back ratio of greater than 50 decibels mean? Somebody pull out a smartphone and go to your calculator on the smartphone, please. Okay, so 50 decibels is 5 bells, which means we're going to take 10, raise it to the 5th power. 10 raised to the 5th power is what? Okay, it's 100,000. 100,000. So when we talk about this antenna having a 50 decibel front to back ratio, that means it has 100,000 times more signal on the front than it does at the back end of the antenna. And that's what this antenna is designed for. 100,000 times stronger signal at the front of the antenna than at the back of the antenna. So that number 50 decibels is a huge number. That's why I really wanted everybody to think about that. The other thing to look at is that its electrical beam width, this is the 3 decibel beam width. What is 3 decibels? Why is that important? Again, we're talking about decibels. We talk about this in the general class radio license class that we teach. decibels are logarithmic numbers, okay? And so the 3 decibel is a doubling or a halving of the power. So 3 decibels represents a double or half of the power. So the beam width of this antenna, when we have half of the power beam width is 67.5 degrees. This is not a rifle, it is a shotgun. Or another way to think about it, it's not a laser, but it's a broad flashlight with a spread beam, okay? So it's not something that as soon as we point at the fox, you're gonna get this huge peak. It's 2-to-1 bandwidth is 67 degrees apart. That's pretty wide. The H field, anybody know what the E field is? The electrical field when we talk about horizontal polarization or vertical polarization. Anybody know what the H field is? That's the magnetic field, and it's 90 degrees opposite from the E field. But when we talk about polarization of an antenna, we talk about it in the E field. And so when we have a handy-talkie with the antenna vertical, that's the E field polarization, where the H field is going to go like this. Does that make sense? Okay. But nevertheless, the important thing is this is not a laser beam. It's a broad band antenna, or a broad beam width antenna. So you have to remember that and keep that in mind. And in fact, here is the E pattern. And if we take a look, this line here represents 3 decibels, or half the power at this line here. And so you see it goes from there over to here, where we got the half power. So you see how broad 67 degrees is. Does that make sense to everybody? So again, think of it as a shotgun, not a rifle. And the other thing that I've seen a lot of new fox hunters do poorly is they just keep their antenna in one spot. It's much better to continually move the antenna back and forth as you listen to the signal, because remember, you're trying to look at your S meter. You want a receiver with a good S meter. I'm going to show you a good S meter and a poor S meter when I go to the camera here in a minute. But because you're going to look at the S meter, and we're going to use attenuators so that when we've got the signal really loud, the S meter may only be at 1/2 or 2/3 full strength. And then you can see it go down or go up, depending on as you get closer to the signal or away from the signal. So you really would like an S meter, say with 10 full bars, where you can, at full strength, you got 10 bars, at half strength, you got 5 bars. So when I use an attenuator to cut the signal down, as I'm listening and I get a really loud signal, I'm going to probably set it to where I've only got 5 bars on the S meter. Then if I'm using a null antenna, I'd like to see the bars go down to 0. Or if I'm using a peak antenna, I'd like to see the bars go up to 10. But I'm constantly moving my antenna back and forth rather than pointing it like a rifle. I'm thinking of it as a shotgun or a searchlight. Does that make sense? Okay, another type of peaking antenna system is a Doppler array. And actually, it's more of a pseudo Doppler system. And we'll talk about this and how it works. And there's some advantages to that. But the Doppler array, most of the time, you're going to use it as part of an automobile search because it requires a series of at least 4 antennas. You could have 8 antennas. And these are set up in a particular pattern because you have to calibrate the Doppler system to where the antennas are in direction to the front of the car and the back of the car. And then if you look at this, the Doppler control system, here you've got 0 degrees, this is 90 degrees, 180 degrees, and 270 degrees. So how does this work? Well, let's think, instead of having 4 different antennas, oh, I'm sorry, I didn't mean to do that. Let me go back. Just a minute. Share my screen again, sorry. Okay, there we go. Okay. So instead of having 4 antennas like I did here, imagine that I've got one antenna that is rotating in a circle. So I've got one antenna rotating in a circle. And that antenna is receiving a signal. And as it moves closer to the signal is going to shift up using the Doppler effect. As it moves away from the signal is going to shift down using the Doppler effect. So imagine I've got one antenna on the top of my car and it's spinning around at 10,000 RPM. A little bit dangerous, but think about it doing physically. So as it gets, if I am the hunter and say Jeff is the fox, as that antenna is moving towards him, the frequency is going to shift up. As it moves away from him, the frequency is going to shift down. Now I can do that with a mechanical antenna spinning at 10,000 RPM. The other thing I can do is use a set of 4 antennas and then electrically spin it. Electrically spin it by moving from one antenna to the next at 10,000 RPM so the antennas don't have to physically move. And all I have to do is have software that figures out, all right, at what point as the signal rotates through A, B, C, and D antennas, at what point does the frequency get highest? And at what point does the frequency get lowest? And then it will point to where the antenna is, where the fox is. Does that make sense? So that's how a Doppler system works. And the advantage is that it can very quickly tell the direction of a signal source. So it's really good if you've got a kerchunker that's driving around town and just kerchunks the repeater for 5 seconds and then drops out. It's really hard to use these tape measure YAGIs or this loop antenna when somebody's just doing it just for 5 seconds. But with the Doppler, this can pick it up really quickly because remember the antenna is electrically rotating 10,000 times per second, and it will quickly give you direction to your source. The disadvantage is it's a lot more expensive. There are a couple of places in the US that still produce these. There's a lot of online information if you wanted to build your own. You need a fairly large antenna array with at least 4 identical antennas to set in a particular pattern on the roof of your car. The other thing is there can be multipath confusion with these Doppler arrays, depending on whether the signal's bouncing off a thing. And it's not really good for a close in. As you get closer to the source, it's not as good as the YAGI or the nulling antenna is. All right, so what kind of antenna can we use for null searching? Well, we can use these small loop antennas. This is a loop antenna from Arrow Antennas, the company that makes the YAGIs. And this, I think, is about 50 or 60 bucks. And it's a null antenna. It's not good for transmitting, but it does receive. And it has a fairly sharp null. The important thing is that unlike other directional antennas, it's used to null. And the null is along the face of the antenna, either this way or this way. It's not off to the side. The null is either front or back because the signal will be nulled out because it's hitting both arms of this loop at the same time. And it can provide a fairly sharp null. It's got a 5-degree beam width on this null. But the problem is you've got an ambiguity. The signal could either be in front of me or behind me because it will null on both sides. And so what you've got to do in order to find the direction of the fox is that you've got to move off of the direction of the fox in order to triangulate. And that's the other thing that I found is people that are new to fox hunting, they take a bearing and then they tend to just walk along that bearing and continue going on that bearing. That's not the best way to do fox hunting. The best way to do it is to take a bearing and say, okay, somewhere between this position and that giant elm tree down at the end of the block is where the transmitter is. Instead of walking on that same line, I'm going to walk maybe 90 degrees off of that line and go 400 or 500 feet away and then take another bearing and then see where the bearings intersect. so I can get a triangulation. Does that make sense? And you do the same thing with this null. In fact, this antenna, when we did the Let's Talk repeater, and we went down to the state police dispatch center when we found it, this is the antenna we used to actually locate the actual radio that was malfunctioning, because there were 3 towers down there, and we ended up starting out, it was me and Phil Sherrod and Randy and who else? I think a couple other guys. Anyway, when we took the readings, we were about 5 to 7 miles out. We triangulated and we came in, and so we were about a mile away, and we looked, and there are these 3 huge towers down at the state police dispatch center. So we're thinking, oh, great. Well, it's got to be one of those towers. So we go down to this is Sunday afternoon. We go down to the dispatch center and we look at the 3 towers, and remember the beam width for our YAGI antennas is 67 degrees. And each of these towers had 10 or 12 VHF and UHF antennas up and down the length of the towers. So what we ended up doing is stop using the YAGIs and went to one of these loop antennas, and then we were able to use it, and we were able to track down, okay, it's this tower right here. Then we started going up, and we could point, okay, it's the 3rd antenna down on the left. And because it was that sharp of a null that we were able to do it. So we looked, and there were 6 antennas on this tower. And we said, it's the 3rd antenna on the left. And so we walk up to the front door, and they've got a camera. Their door's locked because it's a dispatch center. Got a bunch of weird looking guys dressed like us with these weird antennas. And we knock on the door, and they go, yeah, what's up? We said, well, we dropped Bill Jorgensen's name. So, because we figured that would get us in. Yeah, Bill Jorgensen, we're with the Williamson County Amateur Radio Society, and Bill Jorgensen wanted us to find your stuck transmitter, and we got it located. Click, they let us in. They said, okay, what's going on? So we said, we got the people out there, we said, you got a stuck transmitter, and it's whatever radio is attached to it, that antenna right there. And we pointed to it. And the thing that was great, these people, these are the radio professionals, what they're going, yeah, we've been having trouble not being able to talk to anybody. We were wondering what's going on. We said, well, whatever radio is attached to that antenna, turn it off. So they walked in there, they unplugged it, problem went away. So they pulled it out of the rack, sent it off, got it repaired. But they've been dealing with this for about a week. But we were able to localize it with this loop antenna. All right, so what does a Fox transmitter look like? And again, I'll pull these up and show everybody on the camera after the thing. So I've got 2 different Fox transmitters here. We've got this one that is a very small one that's actually in a toothbrush tube. This is a 15 milliwatt transmitter, and it's very easy to hide. And then we've got another one here that's in an ammo box, and I've got a demonstration here. And this uses a handy-talkie and this little Pecan controller from Bionics. And again, the place to get all this information I will have online at the end of this lecture for everybody to be able to find. The ammo box, this is a little concerned because it looks like it could be an IED. And so whenever we hide these, we make sure we let the police officers in the city or the county know that, yeah, we're ham radio guys and we're hiding this thing for amateur radio direction finding. And in case somebody calls in, it's not anything dangerous. We're just using it as a transmitter. Then the other useful equipment is going to be attenuators. As you get close to the Fox, your signal strength meter is going to be full scale. And remember, we want to watch that signal strength meter change. So you've got to knock the signal strength down a little bit. And you can use manual or passive inline resistors. You can use an offset attenuator, or you can use an automatic attenuator. And I've got demonstrations of both of these. So this is a manual inline attenuator that just uses resistors. And you can add up, this would cover 60, 70, 75 decibels worth of attenuation. depending on whether you flip these switches in or out. So you put your antenna on one side, the handy-talkie on the other, and you can add additional attenuation to cut the signal down. And what you'll do is you just flip these switches to reduce your signal until your S meter comes to about half strength when the Fox is transmitting. And then you can use your antennas to see the signal strength meter move. Does that make sense? Okay, another option to use is an offset attenuator. This is an offset attenuator here that injects a 4 megahertz signal into the band. And so it's got a 4 megahertz frequency generator, tone generator, and it generates the signal. And then it's got this potentiometer that can adjust the amount of 4 megahertz signal gets put into the frequency. And the reason, remember, if you think back to your ham radio classes, when we inject a signal, you get mixing products. So if I'm listening to a frequency on 146.565 and I put a 4 megahertz signal on top of it, I'll get a frequency at 150.565 and another one at 142.565. Okay, and the reason they chose 4 megahertz is because if you go to 150.565, that's outside of the ham band, and a lot of handy-talkies will not let you transmit at that frequency. So that if you got your radio tuned to 150.565, it will receive, but when you key it, it will not transmit, so you won't blow out the circuitry in this attenuator. And depending on how much you turn the potentiometer, you can add more or less of the 4 megahertz signal in there, so you can attenuate the received signal because you're listening to the mixing product on 150.565. Does that make sense? And as you get closer, you add more attenuation so that you keep your S meter at half scale. And then if you want to really get the Cadillac of all signals, of all trackers, Dave's got one, I've got one to demonstrate, and I'll demonstrate it when we finish the slides here for everybody. This will add additional attenuation automatically. And it's got 9 steps of attenuation, 15 decibels each. And so the maximum attenuation is 135 decibels. Now, I'm a geek and I figured out what 135 decibels is. So that's 10 raised to the 13.5 power, okay? That is 31,622,776 millionths of the signal at maximum attenuation. So you're cutting the signal down a huge amount. That's an amazing number. So we throw out this 135 decibel attenuation, and that doesn't make any, but when you look at 31 trillionth of the signal at maximum attenuation. So when the front end of this receiver starts getting overloaded, it adds an additional 15 decibels of attenuation. And in fact, there's a number right here, and right now it's zero attenuation. When it goes to 1, that'll be 15. When it goes to 2, that'll be 30. When it goes to 3, that'll be 45 decibels of attenuation. Okay, and then these are the resources for fox hunting. The book is Transmitter Hunting Radio Direction Finding Simplified by Joe Moell, K0OV. He's a really nice guy. I've talked to him several times on the phone. He wrote an article about one of our fox hunts here in Williamson County 10 or 12 years ago that was in CQ-VHF magazine. And you can get this. They used to sell it at the ARRL bookstore. It's not there anymore, but I looked up on Amazon and it's 33 bucks. And this is everything you want to know about amateur radio direction finding. The second line here, this is the project for the tape measure antenna. This RDF antennas is a commercial source for fox hunting YAGI antennas. And this guy also, actually, I think he is the United States rep for the VK3YNG attenuators, and he may have 1 or 2 still in stock if anybody's interested. Bionics They do a lot of APRS and GPS stuff, but they produce these Fox Hunt transmitter. And then probably the biggest website that I'd recommend is Joe Moell's website. It's homingin.com. I really strongly recommend that you look at this website. It's got tons of information, lots of stuff if you're interested in it. This other stuff you can find by going to his website there. Okay, let me stop sharing. And then I'm going to come over to the screen and show y'all several different things. Okay. Okay. Come on over here. So I talked to everybody about this paper towel roll, and you can see I've just got the foil going around 2/3 of the way, and this would drop right over your hand talk receiver, and it doesn't work as well as directional antennas, but it's cheap down and dirty and signals far away. This is this is the 15 milliwatt transmitter from Bionics, and it's programmable. There's a little USB plug plugs into the side here. Let me turn this on. You hear what it sounds like as I turn it on. It goes for about 15 seconds, and then it'll be my pulse. So it transmits for 30 seconds and you sit off for a minute. And this is one of them we used to hide. Another receiver, another transmitter we use is this Fox Hunt box. And it's got this is another transmitter controller from Bionics. I've got an old handy talking here and a battery. And all I have to do is turn this on here and you'll hear it. That's like one.
We're going to 146 frequency?
Yeah. And it may be this handy talk I use here is been broken. I can't even read it. And this one, this is, you can see how that would be mistaken for improvised explosive device. You want to be careful. Now, listen to Morse code. M-O-E. So this is used for IARU Fox hunting, where they put a series of 5 of these out in different positions. And so we've got MOE, which is dash, 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 bit. MOI, which is 2 bits. MOS, which is 3 bits. MOH, which is 4 bits. And MO5, which is 5 bits. And they are set up at 5-minute intervals. So each of them transmit for 1 minute. So the MOE would come on for 1 minute, shut off. Then the MOI comes on for 1 minute, shuts off. Then MOS comes on for 1 minute, shuts off. And so you and every minute there's a different one that's on, and then in 5 minutes it comes back, and you've got to locate all 5 different boxes. Yeah, so that was kind of then let's take a look at a couple of different things here. One of the things I talked about was get into the UFO. Come back on. Okay. Now, if you take a look, you can see above the 146, I've got full strength signal, right? So it's got 7 or 8 bars, easy to see. That was easy to see. This one is not easy to see. This one's not easy to see. You see that? It's very small right there. It's just 3 bars. So this is not one that I want to use. I would rather use this one that's got, here you see no bars, and when it starts transmitting again in a second, you see it goes full scale. And then I'll also show you how the offset attenuator works. So I'm getting ready to put the offset attenuator in place. So I'll put the offset attenuator in now. You see, now add more attenuation. You see, I shut off. Now get it. See the difference there? Get rid of all the attenuation. So if there's full attenuation there, and I'll add more attenuation in. So here now I can sort of move this around. As I move it around, there, so I null it out right there. Pretty sharp null. See the difference?
That's the mixing.
This is the mixing between them. Does that make sense?
Which of the arrow antenna loops is that?
This is,
So,
I think this is the large one, but I'll have to let you know. This is the large one. Yeah, this is the large one, and it's not for transmitting, it's only for hunting. And then I've got the, I'm gonna move this box way over there, if y'all don't mind, just a minute, I'll be right back. Now again, in here, I'm going to get a lot of multi-path bounce, so this may not be 100% accurate, but I just want to demonstrate this VK3 YAGI transmitter. So you can see here, it's got, yeah, so it's right now it's using 30 decibels of attenuation. It's shut itself off now. I gotta wait 30 seconds. But this has a tone mode so that as it's transmitting, the tone gets louder, you got more, it gets higher, you got more signal.
So that doesn't have an S meter on it?
No, it's got an auto S meter. And what will happen is you get louder,